And again, the reason is because on Tuesday night, I don't want anybody doing anything except studying for the quiz, so I wanted to give you an extra day on the homework. So here we are for this. I'm going to do, okay, and by tomorrow when you walk in, if you want to be in good shape, I would have done up through part D by tomorrow when you walk in the door. And again, remember, I can record videos today after school, or tonight rather. Right now I want to do level 7, problem number 3. So I did this online last night, but I want to redo it in class. So if you already watched the video or you already got it, you can continue working, and then we will continue on. But right now, level 7, number 3. So level 7, number 3. So this says we have this right here, and they want us to rewrite this rather in sigma notation. So sigma notation. And again, for those who weren't here on Friday, this is all online already. We don't know this is one, sorry. We just know that this is the index. Remember, the index could be any letter. And then we need to find what goes here. Remember, this is called the general form, also known as the nth term expression. When I look at this sequence, I hope you identify that it is this kind of sequence. I hope we can identify the common difference. Stop me if there are questions or the logic breaks down. If we know it is arithmetic, as we discussed on Friday, the nth term of any arithmetic sequence is given by this formula. Right, in orange, this is one of the 2 important formulas for arithmetic sequences. We will need to memorize this, but not for any of the upcoming assessments. In the future, you will need it. Excuse me. Okay. Now, we should modify this general formula to fit the specific situation we have. So plug in A1 and plug in D. Okay, this is called the general form or the nth term expression. Again, you don't have to simplify this if you don't want to. You could distribute the 2 if you want to, but it's not required. This, as you all remember, goes here. And you now need to find the lower bound and the upper bound. Lower bound 98% of the time will be 1. And the way I know that the lower bound here is actually 1 is because notice I assumed that A1 was 2. In other words, I assumed this was the first term. That's totally fine to do. Totally fine to do. We had just assumed this is the first term. And now we need to find, well, we're adding term 1 plus term 2 plus term 3. And the question is, how many terms are we adding? We're not adding 20 terms necessarily. We could have, in other words, this could be term 20. We don't know for a fact. We need to check what term number is this. Right? It doesn't have to be 20. In fact, in this case, it will turn out not to be 20. And the way you check which term number this is just take this and put it right here. So we'll get 20 equals 2 plus n minus 1 times 2. So we just plugged in 20 for a sub n, and then we can solve for what term number 20 is. At this point, there's just some algebra to do. If you can do this on your own, go for it. If you need to check with check with what's happening on the board, feel free to do that as well. And again, if there are questions on the logic, feel free to ask. And the green box is the right answer. Juan?
Oh yeah, I was gonna ask you that.
Anthony?
N
N equals 1. Okay, so notice that for this is the general for arithmetic, and so I said A1 equals 2, right? So I got that from here. So I said I'm going to assume this is the first term, right? Because this is A1. So I'm going to start at term 1 because this is term 1.
So you're doing it based on the first term.
Based on the sequence, right? Good. Questions on this? Rambir?
So is it because we chose to use 20 first? Is that why we couldn't 10 of this?
No. So okay. So remember, with a sigma notation, it's saying in words, it's saying add up lower bound term. So add up from term 1 all the way up to term 10. So this is term 1 of the sequence 2, and this 20 we just found is term 10. Does that work, Rambir? Jennifer? And then we'll come over here.
What if it, like how you said 98% of the time the first term will be 1?
Yeah.
Like, how do you know if it's not? Like, would it tell you?
So like in number 7 when I did, I thought it was just a little bit like more convenient to make this term 2 because they already had like both 2 there. That was just like a choice I made. The only time I think, I don't want to say only, but like anytime it's like an arithmetic sequence or geometric and you can recognize it, we'll almost always just make this 1. Just assume it to be 1. No, I mean. Okay. More questions?
Hey,
Josh?
you said if you recognize the function.
Right. So here we recognize this is arithmetic because every time we just adding 2. Then this is going to be 1. If we recognize that this had been geometric, like this is not geometric, clearly, if it had been, n will almost always again be 1. That's what I'm saying.
Okay, so as long as you recognize it, if you can totally recognize the pattern.
Precisely.
Alright.
Absolutely. Okay. Now let's go to level 8, number 1. So level 8, number 1. And here we have kind of one new formula that we need to discuss, and then we will attack the problem. So the formula says this: for any partial sum, and remember from Friday, a partial sum is when you add up a portion of the terms. So for any partial sum of an arithmetic sequence, the sum equals, so the formula for the sum is S sub n. Remember, n could be the third partial sum, the 10th partial sum, the 20th partial sum, whatever you want. Third partial sum, sum of the first 3 terms. 10th partial sum, sum of the first 10 terms. 20th partial sum, sum of the first 20 terms. S sub n is 1/2 times n, so 1/2 is just 1/2. N is the number of terms times a1 plus an. And this is the formula, as I said, for every or for any partial sum of an arithmetic sequence. So 1/2 is just 1/2. N is the number of terms being added. A1 is the first term. And an is the last term we are adding. We are adding.
So it's like the early question that we had.
Say that again?
The presentation you gave us to just divide it in half or something like that.
No, because the first equation, remember, was this, a sub n equals a1 plus n minus 1 times d. So this was the equation for the nth term. This is the equation for the sum.
Oh, okay.
So now we will use this kind of new equation to solve problem 1 on level 8. Before I go there, I want to make sure everybody has a chance to get this down, and then we will start with problem number 1. So are there any questions on the formula before we go on? Okay. So on level 8, number 1, so level 8, number 1, they want us to find the sum of the first 40 terms of this sequence. So when I look at this, I'm automatically, even if they hadn't told me, I would have written this and I would have identified this. Please let me know if there are questions on that before we go forward. And they want me to find S40, because they want the sum of the first 40 terms, which means find the 40th partial sum. Partial because we're only adding the first 40 terms, not the first infinite terms. We're only adding a portion. So S40. And remember the general sum formula for any arithmetic sequence. If you want the sum, this is the formula we just gave, 1/2 times n times a1 plus an.
I mean, what?
Say that again?
N will equal 1.
N is not 1. Remember, n is the number of terms being added. Right. So in this case, we want to find S40. So go ahead and plug in 40 everywhere you see n, because we want the 40th partial sum. So let's clean this up a little bit. S40 equals 1/2 times 40. And A1, we know what that is. Go ahead and plug that in. Unfortunately, we don't know A40 yet. So here's where we are. So we now need to identify A40. We need to identify A40. And we know, because this is arithmetic, that this formula holds true.
Because when we use the other equation.
And since we want to find A40, we can just use this equation right here. A40 equals A1 plus 40 minus 1 times D. Simplify this equation using what we know. There we have it, A40. Once you have A40, you can plug that back in to your sum equation.